Okay, this is Warmup 920. I'm going to have you copy all of this work, even the tables, and then the 5 words to show me that you listen. So here we go. Being able to use tables to write all 3 types of functions that you have to know for this benchmark coming up at the end of the quarter. So again, looking at this, the X and the Y, the X are your X numbers, the Y is really, if you did function notation, your f of x values. So what you need to do for a problem like this is focus on the y numbers and see how much these numbers are going up or down. Focus on that. That is your first task. See what my y numbers are doing, going up or down. And again, you could get that by taking 11, taking away 6, or 16, take away 11. But you need to start recognizing that this is going up by 5. That is a key number. That is your slope. That is your D number. All of that is your 5 number right there. I could use that 5 to reverse and go up the column because I'm going to need to go to my 0 term, the y-intercept. So going up to 0 on the x column, I take this 6 right here, subtract that 5, and that gives me the y-intercept number. 6 minus 5 gives me 1. That is a key number right there for my y-intercept. First word is blue. Blue. Now I have everything I need to write all types of equations for this. For recursive, here's recursive. Plus that 5 right there. And again, recursive is nothing more than to find the next term, use the one before it, add 5. Both forms of explicit. The first one with that 5 number always in front of x, that's your slope, plus or minus that y-intercept term, that is slope-intercept form, y equals mx plus b. Or of course, using that first term, which is using 5, but not just x, x minus 1 plus that first term being 6. And again, knowing that even though those two look different, those are really equivalent. If I was to distribute this, that would give me 5x minus 5 plus that 6, and then that negative 5 and 6 right there would give me 5x plus 1, the exact equation as this. That's why when you plug in a value for x into both, they give you the same value spit out because they are both equivalent. All right, so there we go. A basic going up by 1 table arithmetic, where this would be a straight line if you graphed it, linear. Next problem. Second word is red. Red. All right, a table that is obviously not adding, subtracting, geometric. So for this, my advice is to focus on 1 and 2 and take these two numbers right here and divide them out. That will give you not your slope, but your R number, your common difference. So 416 divided by 408. If I divide that, it should give me the R number, 416.16 divided by 408. Spits out 1.02. That is my R number. It's not going to be like slope because these lines are curved and don't have a common rate of change. That's just my common ratio, my timesing number. So that's the number I'm timesing all the way down. If you want to use your calculator to prove it to yourself, take those numbers and times by 1.02 should give you those values. To get the 0 term, of course, I'm doing the opposite of timesing by 1.02. I'm really dividing by 1.02. What am I dividing? I'm dividing this 408. Dividing 408 by 1.02 should give me 400. Of course, we don't want to show that division. Dividing by 1.02 is the same as treating it as kind of a ratio and timesing by the reciprocal. So again, even though that looks weird, timesing by 1 over 1.02 is the same as dividing by 1.02. So 408 either being divided by 1.02 on your calculator should spit out 400, or fancy pants, 408 times 1 over 1.02, where you multiply straight across and you end up with 408 over 1.02, which again spits out 400. Either way, gives you 400 for that all-important zero term, the y-intercept term, where your graph, if you were to graph it, where it would touch the y-axis as it's curving up. All right, my equations, here we go. First one, f of x equals f of x minus 1 times 1.02. This is geometric. This is exponential. That's the first one, recursive. For both forms of explicit, I could either use the zero term, which is 400, times that same R number, 1.02, but don't forget to the x power. Can't forget that x right there. And then the first term one, f of x equals 408 times that same 1.02 to the x minus 1 power. All right, here we go. Last problem. Third word is tan. Tan. All right, here we go. This one, way more difficult because your x values are not going up by ones. You need to be able to see a double pattern here. How much my x numbers are going up and how much my y numbers are going up. Because when I do that and I calculate that change in my y numbers and divide it by the change in my x numbers, that little delta means change, that will spit out my slope or my d or my common difference. So again, for this, looking at my x values here, focusing on the positive ones, looks like as I go down my column, this is going up by 2. As I go up my y column, going up by 8. If I look at the next set from 3 to 6, going up by 3. If I look at 18 to 30, looks like it's going up by 12. If I divide any of those pairs, it will give me my rate of change. It will give me my slope. So if I use 8 and divide 8 by 2, it will give me what my common difference is, my slope, 4. Or I could use that other chunk, dividing 12 by 3, to get that same 4. And now the tricky part, that 4 is the rate of change when you're going up by ones on the table. So if I was to fit some numbers in here, like this is 0 in here, and maybe a 2 in here, and a 4 and a 5, I could figure out what those other numbers are going to be going up and finding that 0 number, of course. So that means I'm going up and down by 4s. Here's where it gets tricky. It's going up by 4s, going up by 4s, going up by 4s, going down by 4s, going down by 4s, going up the column. So if I was to fit some numbers in there, the 0 term is 10, take away that 4, so this 10 right here minus this 4 will give me the all-important y-intercept term, 6. And that makes sense because if I take 6 minus 4, that gives me 2, going down the column. That same 10 plus 4 gives me 14. 14 plus 4 gives me 18. 18 plus 4 for the fourth term gives me 22. 22 plus 4 for the fifth term gives me 26. And of course, that sixth term plus 4 gives me 30. So you will have to be able to find your rate of change and then be able to find that zero term by going up or down by increments of 1. This is where it gets tricky. For my equations, of course, for recursive, I use that plus 4 number. That is my rate of change. That is my slope. That is my D number. For my explicits, if I'm using the 0 term, that's 4x plus that 6 right there when I went down a step. If I use the first term there, which might be a little easier for this one, I got 4 times x minus 1 plus that 10. I could use that one because, again, those are equivalent. Distributing that would give me 4x minus 4 plus 10, and then that would give me that same 4x plus 6. They are equivalent. Second to last word is yellow. Yellow. All right, again, going back, you need to know how to write all 3 forms. Recursive, that weird one that's always looking like this, and then both forms of explicit using the 0 term, the y-intercept, or using the first term in the sequence. All right, last word is black. Black. Talk to you in a bit. Good luck.